Now we are going to discuss find the power of KSI subarrays 192 from LeetCode BiWeekly 137. In this question, you will be given an array of n integers. Let's say A1, A2, A3, so on and an integer K. We need to find the powers of all subarrays of size K. Now, what is power? Power is nothing but the maximum element if every element is consecutive and sorted in increasing order. Else power will be -1. Now let's take an example to understand it. Now let's say if our array is given as 1, 2, 3, 4, 3, 2 and 5 and our k was given as 3. Now the subarrays of size 3 of original array are this is my one subarray, this is another subarray, this is another subarray. And so there are 5 subarrays of size 3. 1, 2, and 3 is a subarray. 2, 3, 4 is a subarray. Then 3, 4, 3 is another subarray. Then 4, 3, 2 is another subarray. 3, 2, 5 is another subarray. So total there are 5 subarrays. If the size of the array is n, then there will be n minus k plus 1 subarrays. Okay. Now the power of this subarray is 3 because the maximum element is 3 because as every element is increasing. Now, as every element of this subarray is increasing, so its power will be the maximum element, which is 4. Now, this element is not increasing, so its power will be -1. Now, even this subarray is not increasing, so the power is -1. Even this is not increasing, so power is -1. So the power of original array is 3, 4, -1, -1, -1. So we have to output this. Yeah. Now the only difference between first question and the second question is the constraints. Now in the first question, if n is the size of the array and n can be up to 500 and k can be less than or equal to n. And every element of this array will be of range 10 power 5. Okay. For the second question, if n less than or equal to n less than or equal to 10 power 5. It means the array can be of size 10 power 5 and 1 less than or equal to k less than or equal to n. And every element of this array can be 10 power 6 range. Okay. Now, if you see the constraint for the first question, n can be up to 10 power 5, right? Now it means I can write a solution which runs n square times and it will get accepted because n square is nothing but 500 into 500, which will be 25 into 10 power 4. So this range would get accepted. But for second question, as n is 10 power 5, now it means we need to run a solution for O of n. Now let's talk about the different approaches. Now the first approach that comes to my mind is the brute force approach. Here, now here I'm going to check all the possible subarrays of size k And I'm going to check whether what is the power of these particular subarray, and what is the power of these particular subarray, and so on. So I'm going to check all subarrays of size k, and I'll calculate the power of all subarrays. Now, if 1, 2, 3, 4, 3, 2, and 5. If this is the original array and our k was 3, right? Now I'm going to check. I'm going to run two for loops. Where the in outer for loops starts from uh, I is equals to 0, and where I'm going to check each and every possible subarrays. So I'm going to start I is equals 0, and I less than I less than n minus k, because I need subarrays of size k, right? So I can't run more than this. Like this. And for each index I, I'm going to check the subarray starting from index I. So if I'm at index 0, I'm going to check the subarray starting from 0, which is of size k. Now, if I'm at index 1, I'm going to check the subarray starting from index 1, and so on. Okay. So for my out inner for loop should start from I is equals to, sorry, j is equals to I plus 1, and j less than j less than I plus k, and j plus k. Basically, I'm checking now my inner for loop is starting from the first index. I'm going to check whether the difference between these pair of elements is 1 or not, whether these pair of elements is 1 or not, so on, for size k. Now, if my array of j minus array of j minus 1 difference is 1, so here I'm going to maintain a count variable, because now if uh, I'm going to check subarray of size k, right? So now I'm going to check k minus 1 conditions, k number of k minus 1 number of times, and check whether the difference of adjacent elements is 1 or not. So if this is 1, I'm going to increase my count by 1. Else I'm going to break from it, because the subarray starting from 1 does not have k consecutive elements which are increasing. Now, if my c is equals to k minus 1, it means I found a subarray. So initially, I'm going to, let's say if this is our array, now my I is at 0th index, right? So I'm going to check for subarray starting from 0, and I'm going to check whether the pair of these element is 1 or not. Now 2 minus 1 is 1, so my count will be 1. Now the difference between 3 and 1 is again 1, so my count becomes 2. Now, as I reach a subarray of size 3, now I'm going to check whether this C value is equals to k minus 1 or not, which is k is 3 minus 1, which is 2. Because here we are going to make k minus 1 comparisons. So if this is equal, so if it is k minus 1, it means the subarray starting from index I is increasing. In that case, I'm going to add I plus kth index element. So I'm going to add this particular element. Now for next, whenever my I becomes 1, my j, whenever I becomes 1, whenever my I becomes 1, my j will start from I plus 1. Now I'm going to check whether these two pair of elements is 1 or not. Now 3 minus 2 is 1. Again, 4 minus 2 is again 1. So as 3 minus 2 is 1, I'm going to increase my count. And for next 4 minus 3 is again 1. So I'm going to increase my count. Now I reached a subarray of size 3, right? Now again I'm going to check my whether my C is equals to k minus 1. So it is equals to k. So I'm going to add this particular element. Okay. So I'm going for every I am going to check the size of k size subarray. Else, if this is not the case, I am going to add minus 1 because this particular subarray, let's say if we take this subarray, in that case, the 4 minus, initially I'm start, my I is at index 2, my j will be at this particular index. Now 4 minus 3 is 1, so my c becomes 1 from 0 to 1. Now for next j, I'm going to check these two pair of elements, right? 3 minus 4 is minus 1, which is not equal to 1. So in that case, I'm not going to increase my count. So if we reach a size, as we reach size k, subarray, in that case, our c is not equal to k minus 1. So in that case, my power will be minus 1. Now, if we talk about a time complexity, now I'm going to check, I'm checking for every possible subarray starting at index I, right? So it means worst case, this outer loop will run n number of times, or else n minus k number of times. So and my inner for loop will again run for k number of times, or k minus 1 number of times. So our overall time complexity will be n minus k into k minus 1. So if my k is given as n by 2, then n minus n by 2 into n by 2 minus 1. Now, if you remove this one, then this can be n square by 2 minus n square by 4. Worst case, it will be n square. So if you generalize this, n minus n by 2 will be n by 2, n by 2. This will be n by 2, and this will be n by 2 again. Now, this will be n square by 4. Now, if we represent in a big O of n, it will be O of n square. And space complexity will be, now I'm using an answer array to store all these answers. In worst case, I'm going to store, no, like I'm going to store O of n minus k plus 1 elements, right? So my space complexity will be O of n minus k plus 1. Okay. This will get accepted for first question. But for second question, as the constraints are high, so we need to optimize our code. So the second approach I'm going to discuss is now. Let's say 1, 2, 3, 4, 3, 2, 5. This is our array. Now I'm going to check. First, I'm going to check the subarray of size k. So I'm going to check whether the subarray of size k is increasing or not. So initially, I'm going to start at index 1. Now I'm going to start at index n. I'm going to check whether this pair of elements difference is 1 or not. So if a of I minus a of I minus 1 is 1, it means it is these two are increasing, right? And sorted. So in that case, I am going to increment my count by that. So now initially my C will be 0. So I'm going to start at this particular index. So I'm going to check whether these two are difference is 1 or not. As 2 minus 1 is 1. So I'm going to increase my count. Now my I will get increase. No. I'm going to check these two pair of elements. Again 3 minus 2 is again 1. So I'm again going to increase my count. Now whenever I reach index I to 2, index 2, then it means from starting index 0 to index 2, I have a subarray of size k, right? So in that case, now I'm going to check whether whether the value stored at count is equals to k minus 1 or not. If C becomes k minus 1, then it means this subarray, this particular subarray is increasing and it's sorted. So in that case, the power of this subarray, power of this particular subarray will be the maximum element, which is 3. So in this case, I am going to add a of k minus 1 to index. Else, I am going to add minus 1 as the power into my answer array. Now, instead of checking for each subarrays, what I am going to do, I am going to use this particular C and calculate the powers for each of these subarrays. Now, as I found the subarray for index 0, right? Starting at index 0. Now I am going to start at index 1 now, and I'm going to use the values stored in C for this particular index I. Now, whenever it whenever I am at index 1, my subarray starting at 1 will be this, and now previously my subarray was this. If we observe carefully, the only element that got added to my previous subarray was 4, and element that was removed was 1. Okay. Now, no, I removed 1, right? I removed 1. If my difference between this pair of element and this pair of element is 1, it means this pair contributed a value 1 to my C, right? So in that case, as I am removing this pair of this element from my subarray, if it was contributed a value to my answer, which is C, so in that case, I am going to decrement it. So now I am going to start at index I is equals to 1 and I less than n and I plus plus. If the difference between these two pair of elements is 1, it means these two elements contributed a value to my answer. So if the difference between nums of, sorry, let's say A, right? We took A as the difference between AI minus A of I minus 1 is 1. It means these two elements contributed a value to my C. Then in that case, I'm going to decrement it. Now, if now this 4 got added to my subarray, right? Now, if the difference between this pair of this element and this element, if the difference between this pair is again 1, it means these two are increasing. So in that case, I'm going to increment my C. If A of I plus k minus 1th index element minus A of I plus k minus 2 element difference is 1. That's it. I'm going to increase that. Now, now if Now C is again k minus 1. It means this value again contributed a value to my uh, subarray, right? So in that case, I'm going to add a of I plus k minus 1th index element because this particular element will be the maximum element. So this will be the maximum element. Else my power will be minus 1. Okay. Now, now for here, so our C was 2 and our index was this, right? Now for this pair of index 1, subarray starting from index 1, we found the answer, which is C. And when we move for the next pair, now I 0, 1, 2. Now for subarray starting at index 2, as the difference between these two pair of elements is 1, 3 minus 2 is 1. So as 2 was removed from this subarray, so we need to decrement our C. Now, whenever now for next subarray will be this, right? 3, 4. Now our next subarray will be this, starting at index 2. Now, as we added 3 to our subarray, if the difference between these two pair of elements is 1, 3 minus 4 is 1. So it is minus 1, right? So this will not be this two will be not increasing, right? So in that case, this will not contribute a value to our answer. So in that case, we will not increment our C. So in that case, our C will be 1, and which is not equal to k minus 1. So we will add minus 1 as an answer for this particular subarray. Now, when we move for the next pair, now, whenever we increment our next I, for next I, our C was 1. Now for this, the difference is we have removed 3 from the subarray, right? Now, if the difference between 4 minus 3 is 1, yes, it is 1. So we have to decrement our C because this 3 was initially contributed a value to our answer. Now, for the next subarray, this will be our next subarray. Sorry. mm, This will be our next subarray. Now, if the difference between these two pair of elements is 1, if 2 minus 3 is 1, no, it is minus 1, right? So this is, 2 will not contribute answer to this subarray. So I'm not going to increase my C. So my C will be again 0, which is not equal to k minus 1. So I'm going to add minus 1. Now, now let's generalize the pseudocode. Now, if you are given a solve function where we have a array a, n size of the array, and k, we first going to initialize an answer array, which is 0. And we'll take a counter variable c 0. Now, I'm going to iterate from I is equals to 1 to I less than k, and I'm going to check first k size subarray. If a of I minus a of I minus 1 difference is 1, so in that case, I'm going to increment my C. So I first found the values for first subarray starting from 1. Now, if my C is equals to 0, sorry, k minus 1, in that case, my subarray starting from 0 will be increasing, right? So in that case, my power will be element at k minus 1 index. I'm adding a of k minus 1 index element. Else, I'm going to add minus 1 as the answer. Now, as I found the power for the first subarray starting from 0, Then I'm going to, and then the only thing I'm going to do is I have to make use of the value C, and if if the for the next pair of subarray, one element gets added and one elements get removed, right? So I'm going to make use of this C to check the further element. So for I, int I by 1, I'm going to start with index 1, I less than n minus k, I plus. If my difference between the first pair of elements is 1, a of I minus a of I minus 1 is 1. It means I have removed this element, right? So if the difference is 1, so I have to remove a 1 because it contributed a value to value C. If a of I plus k minus 1, because the element that we added and its previous element difference is 1, means I'm going to increase my C. Now, if our C is again equal to k, then that particular subarray is increasing. So in that case, I'm going to add a of I plus k minus 1th index element. Else I'm going to add minus 1 as the power. So as at last I'm going to return answer array where power of the entire subarray contains power of entire array contains. Now, if I talk about time complexity, my so this for loop will run k number of times. Okay, so it will run k number of times plus this for loop will run n minus k number of times. Okay, so then overall time complexity will be O of n. Now, the space complexity will be same as previous because there will be O of there will be n minus k plus 1 elements as the answer as power of the entire array. So this will be my space complexity. Yeah. Thank you.